Most students get load factor wrong, not because they don't know the formula, but because they don't know what it means. Today we fix that from first principles. Before numbers and formulas, let us understand something you have already felt. A car brakes hard. You feel pushed into your seatbelt. A swing reaches the bottom of its arc. You feel heavy, pressed into the seat. Standing still right now, you feel completely normal. That normal feeling is 1g, 1 times the force of gravity on your body. In straight and level flight, a pilot feels exactly 1g. The aircraft is in balance, nothing unusual. Here is something to carry into the next slide. Pilots call this feeling G, engineers measure it as load factor. Same feeling, same number, two perspectives. We put a formula to it next. Here is our aircraft in straight and level flight. Two forces act on it. Lift, the upward force the wings generate as air flows over them. Weight, the downward pull of gravity on the entire aircraft. In level flight, these two forces are equal. Lift equals weight. Altitude is maintained. Look at the definition on screen. Load factor is the ratio of lift to weight, the structural load the aircraft carries compared to level flight. Load factor equals lift divided by weight. In level flight, lift equals weight, so load factor equals 1. That is 1g. The same feeling from the previous slide. Normal, nothing unusual. First rule: any question that says straight and level flight and asks for load factor, the answer is always 1. No calculation, always. Look at this aircraft in level flight. Lift points straight up, every bit of it directly opposing gravity. Nothing wasted. One thing to understand before the next slide: when a pilot banks the aircraft, the wings tilt to one side. That tilt is what makes the aircraft turn. The angle of that tilt is the bank angle. Watch what happens to lift when those wings tilt. The aircraft has banked. Look at the lift arrow. It tilted with the wing. It is no longer pointing straight up. Any force can be split into two directions. Up and down is vertical. Sideways is horizontal. Each part is called a component. Tilted lift now has two components. The green arrow, the vertical component, still fights gravity, pointing straight up. The red arrow, the horizontal component, points sideways. That is what turns the aircraft. Here is the key. For the aircraft to maintain altitude, the vertical component must still equal weight, but only part of total lift is now fighting gravity. The rest is turning the aircraft, so the wings must generate more total lift than in level flight. Total lift is now greater than weight. The pilot feels heavier. G is increasing. Load factor is increasing beyond 1. This is exactly where the formula comes from. The vertical component of lift must equal weight to maintain altitude. That is what we just saw. One relationship from trigonometry makes this precise. Cosine of the bank angle, cos theta, tells us what fraction of total lift is acting vertically. That fraction must equal weight. So lift multiplied by cos theta equals weight. Rearranging, lift divided by weight equals 1 divided by cos theta. Load factor equals lift divided by weight. So load factor equals 1 divided by cos theta. The formula came directly from the physics on screen, not from a textbook, from what we just proved together. Let us apply this. Take a 60-degree bank. The cosine of 60 is 0.5. So load factor equals 1 divided by 0.5. That gives us 2. At 60 degrees of bank, load factor is always 2. The pilot feels twice their body weight pressed into the seat. That is 2g. Remember this number. Two things before the test. Every aircraft has a structural limit, a maximum load factor it can handle safely. Exceed it, and the structure is at risk. This limit is expressed as a g value, for example 3.8g. And as load factor increases, the wings produce more lift. More lift always generates more induced drag. Induced drag is the drag produced directly from generating lift. Higher load factor, higher induced drag. Always. Three ways this is tested. Type 1. Bank angle given. Find load factor. Apply 1 divided by cos theta. 60 degrees is always 2. Type 2. Load factor given. Find bank angle. Reverse the formula. Load factor 2 means cos theta is zero point 0.5, which means 60 degrees. Type 3. Two statements given. Find the correct combination. Read each statement independently against the formula. Verify each separately. Then pick the combination. Never read them together. The formula never changes. Only the question direction changes. 5 questions. Apply everything. Answers on the next slide. All 5 answers are B. Question 1. Cosine of 60 is zero point 0.5. Load factor equals 1 divided by zero point 0.5, which is 2. Question 2. Load factor depends on bank angle only, not airspeed. Classic trap. Question 3. Load factor 2 means cos theta equals zero point 0.5. That gives 60 degrees. Question 4. Load factor equals 1 divided by 0.259, which is 3.86. That exceeds 3.8 G, not within limits. Question 5. Higher load factor means more lift. More lift means more induced drag. All B. Did you second guess yourself? That is exactly what happens in the exam. Trust the formula. Clear concepts, clear exam. See you in the next one.